Welcome to the Corval Group Training Module for Ammonia Awareness. The purpose of this training is to increase a worker's ability to identify, avoid, and control hazards associated with working with or around ammonia. In this module, we'll discuss terms and definitions relating to anhydrous ammonia, NH3, typically just referred to as ammonia. Identify primary characteristics and facts of anhydrous ammonia. OSHA regulations relating to ammonia. Health effects and safe work practices when working with and around ammonia, and the worker's right to know about chemicals that you may be exposed to in the work environment. Some of the terms that will be discussed in this module include anhydrous ammonia, permissible exposure limit, PEL, time-weighted average, TWA, short-term exposure limit, STEL, immediately dangerous to life and health, IDLH. Definitions. Anhydrous ammonia, NH3, is a clear colorless gas or colorless liquid under pressure with a characteristic pungent smell. It dissolves in water to give a strong alkaline solution. Permissible exposure limit, PEL. Simply put, the PEL is a legal limit to which a worker can be exposed to a chemical substance or physical agent. For chemicals, the chemical regulation is usually expressed in parts per million, ppm, or sometimes in concentrations related to a known measurement of air, such as a milligram per cubic meter of air. Time-weighted average, TWA, is an average of the exposure concentration spread out over the entire workday. There may be periods during the day where the exposure is higher or lower, but the average exposure for the 8-hour workday cannot be exceeded in any 40-hour work week. Short-term exposure limit, STEL. The STEL represents acceptable concentrations of exposure over a short period of time, usually 15 minutes, as long as the time-weighted average is not exceeded. Immediately dangerous to life and health, IDLH. IDLH is intended to assist with identification of any condition that poses an immediate or delayed threat to life, or that would cause irreversible adverse health effects, or that would interfere with an individual's ability to escape the hazard unaided. Characteristics and facts. Ammonia is a toxic gas or liquid that, when concentrated, is corrosive to tissues upon contact. Exposure to ammonia in sufficient quantities can be fatal. One of the highest production volume chemicals in the U.S., concentrated ammonia is used in manufacturing, refrigeration, and agriculture as a fertilizer. Household ammonia is much less concentrated. It rarely causes burns, but it does cause irritation. There are two distinct forms of ammonia. We can just think of them as diluted, aqua, and pure, anhydrous. Aqua ammonia is ammonia gas that has had water added to it. Aqua ammonia is found in most homes in the form of cleaning products. In addition to cleaning products, it is used in numerous manufacturing and food processing applications. Anhydrous ammonia is pure ammonia, and its uses range from fertilizer, by far the biggest use for ammonia, to refrigerant. At the Corval Group, our primary exposures are in the refrigerant category. As a result, we will primarily focus our training on anhydrous ammonia. Characteristics. We have already learned that ammonia is colorless and has a pungent smell. We have also learned that when mixed with water it becomes a strong alkaline. Other items to note. For most, the odor is detectable at very low concentrations, typically about 5 ppm. However, persons with prolonged exposure to ammonia will lose their ability to detect the odor, olfactory fatigue. Ammonia commonly exists as part of a solution. Concentrations of 25 ppm can become irritating to the eyes, nose, and throat. However, persons with prolonged exposure to ammonia will lose their ability to detect the odor, olfactory fatigue. Ammonia commonly exists as part of a solution. Ammonia expands rapidly as it changes from gas to liquid. A cubic foot of liquid ammonia will expand to 855 cubic feet of gas. Anhydrous ammonia, NH3. A poisonous visible vapor cloud is produced from contact of ammonia with water. Lighter than air, so it can become airborne and blown around easily. If in a moist atmosphere, for example rain or fog, anhydrous ammonia begins to bond with water molecules, and this causes it to be heavier than air. Ammonia dissolves readily in water-evolving heat, exothermic, to form ammonium hydroxide, a corrosive, alkaline solution. Ammonia reacts violently with strong oxidants, acids, halogens, and many heavy metals. Ammonia is corrosive to copper and galvanized surfaces. When ammonia is heated to decomposition, it emits toxic fumes and nitrogen oxides. Liquid ammonia will attack some forms of plastics, rubber, and coatings. When ammonia mixes with gas and/or air, it forms an explosive mixture. Lower explosive, flammable limit in air, LEL, 15%. Upper explosive, flammable limit in air, UEL, 28%. Containers may explode when heated. Ruptured cylinders may rocket. Dangerous concentrations of ammonia gas will occur quickly in enclosed or poorly ventilated spaces. There is no antidote for ammonia toxicity. In these photos, you can clearly see the impact of a wet or humid environment. In the picture on the left, the ammonia has been released in a dry environment. Note how the cloud goes straight up. You can also see a lower cloud in the background. It is possible that as the cloud migrated, it found moisture and became heavier than air, dropping back down. Looking at the picture on the right, you can see the ammonia cloud is on the ground. This is a result of wet environmental conditions causing the ammonia to bond with water molecules and become heavier than air. Always know the wind direction when working with or around ammonia. Liquid and gas ammonia expand and contract with changes in pressure and temperature. For example, if liquid anhydrous ammonia is in a partially filled closed container and it is heated from 0 Fahrenheit to 68 degrees Fahrenheit, the volume of the liquid will increase by about 10%. If the tank is 90% full at 0 Fahrenheit, it will become 99% full at 68 Fahrenheit. At the same time, the pressure in the container will increase from 16 pounds per square inch, psi, to 110 psi. OSHA has not developed specific rules related to ammonia for construction workers. However, there are a number of regulations that have an impact on how worker exposures are addressed. This includes 29 CFR, Code of Federal Regulations, 1926.55. This regulation deals with exposures to gases, vapors, fumes, dust, and mists in the workplace. 29 CFR 1926.28 and .95 deal with the requirements associated with PPE. General industry does have more applicable rulemaking with respect to storage and handling of ammonia. These rules may be applicable when working in some of our clients' facilities. OSHA has established exposure levels to aid in understanding the effects of ammonia on the human body at known concentrations. OSHA has determined that exposures of concentrations of no more than 15 minutes at 35 ppm will not have harmful effects to the worker. A permissible exposure limit, PEL, of 50 ppm has been established. This exposure is based on the average exposure over an 8-hour time period and a 40-hour work week. No adverse health effects should be experienced at these concentrations and levels. Should exposures exceed the OSHA limits for short-term exposure, or the permissible limit, controls must be put into place to reduce exposure. This may be 1. Engineering controls to reduce the concentrations of ammonia. 2. Administrative controls, such as worker rotation to minimize the worker's time of exposure. And 3. Personal protective equipment to protect against the hazard. Finally, OSHA has established a level at which ammonia is considered to be immediately dangerous to life and health, IDLH. This level has been established at 300 ppm. Working in exposures at these concentrations would require special equipment consisting of full body protection and respiratory protection. Right to know. All workers who are or may be exposed to chemicals or compounds that could have adverse health effects have a right to know what those effects could be and what they can do to protect themselves. Corval Group subscribes to a third party to manage our chemical data information called MSDS Online. All Corval Group computers and phones are set up with a direct link that will allow immediate access to Safety Data Sheets, SDS. This sign can be found on Corval Group job sites and provides all necessary information for you to obtain any desired safety data sheet. The SDS will provide information relative to the chemical makeup of the product, health hazards, control measures, and so on. Signs are a great way to provide necessary information in the workplace. However, the sign may not always be where you are. Having the SDSs readily available on Corval Group's computers and phones is a great benefit. But what if you're not near a Corval Group phone or computer? In the event of an emergency involving a chemical exposure, the number to be called can also be found on your THA, which should be in the possession of someone in your work group at all times, as well as on hard hat stickers. As with any injury or safety hazard, contact your supervisor and inform them of any and all chemical exposures. Ammonia does pose significant health hazards. It is highly corrosive to human skin. The eyes, nose, throat, and lungs are very susceptible due to the way ammonia bonds with water molecules. The moisture in our eyes, nose, throat, and lungs will quickly bond with the ammonia gas. Due to the previously discussed ability to smell ammonia at low concentrations, our bodies provide a warning system. For most, the odor threshold is less than 20 ppm. There are 3 primary ways in which we can be exposed to the harmful effects of ammonia: inhalation hazard, skin contact, and eye contact. In addition, ammonia can be ingested, but this is a very uncommon route of entry. Acute or short-term health effects of exposure to ammonia can range from burning of the skin or eyes to pulmonary edema, a condition where fluid can build up in the lungs and cause severe shortness of breath. Immediate medical treatment should be sought for this condition. Ammonia burns can result in permanent scarring of the affected tissue. Chronic, long-term, or repeated exposure can result in asthmatic attacks and permanent damage to the lungs. Symptoms of exposure include eye and respiratory irritation that may present as tearing of the eyes or impaired vision, hoarseness, or violent coughing with difficulty breathing. Burns can be as severe as 3rd degree. Should you experience any of the above symptoms when working around ammonia, leave the area immediately. Warn others and contact your supervisor. All employees and subcontractors are empowered, authorized, and obligated by the owners, president, and leadership of Corval Group to stop work at any time for any unsafe condition. All employees and subcontractors are expected to stop working until the hazard or risk has been resolved. The stop work authority can be difficult for employees to embrace because of the fear of losing their job. Be assured that no employee will ever be penalized for using stop work authority. At the Corval Group, the primary risk of exposure to ammonia lies in working with refrigeration systems. However, many of our clients have ammonia present in their facilities, and as such, we may find ourselves working in close proximity to ammonia storage tanks or process systems that pose a potential risk. In all cases, understanding our surroundings and the hazards present is vital to ensure that we are prepared and protected in the event of being exposed to ammonia. Your site-specific work plan will provide specific information related to your project and the hazards present. If you're working with ammonia, some components relative to safe working practices may include various types of enclosures and/or ventilation systems, as well as personal protective equipment. Depending on the degree of exposure, PPE may include respiratory protection, eye protection in the form of splash-resistant chemical goggles, face shield, chemical-resistant gloves, suit, and boots. The level of required PPE will vary with the level of exposure. Being aware of and prepared for all hazards that may be encountered during the course of our workday is vital to ensuring our safety. What would you do if you were assigned a work task, entered the area, and saw this danger sign having no idea that this hazard was present? Please listen carefully to the following message from Corval Group President Jim Simon. In summary, ammonia is a very common, highly toxic, and corrosive product. Even in small quantities, ammonia exposure can have very serious and adverse effects on our health. Always remember that the characteristics of ammonia will change with changes in temperature, pressure, and environmental conditions. If ammonia is present in your work environment, make certain that you have received the proper information, training, and tools to perform your task safely. Thank you for participating in this CoreVal Group training module. Remember that no training can possibly identify all tasks, hazards, or situations that we encounter. Always remember how important your role is in identifying hazards. Always take the time to plan your work and analyze the hazards associated with each task. If you have any questions, contact your supervisor or safety representative.